What's up, scholars? Today we're talking about factoring the difference of two squares. Alright. Oh, I just marked a pen on my chin. What are you going to do? Anyway, let's factor the following expressions using an ACB tree. Sounds simple enough. Let's see, we've got 4x squared minus 1. We're definitely missing something here for an ACB tree because this is supposed to be in ax squared plus bx plus c form. Interesting. All right, well, let's identify a is going to be the number in front of x squared, which is 4. B is supposed to be the number in front of x, which is nothing. That's 0. There's no x term here. And c is the number by itself. Well, that's -1. All right, got it. So if we're doing our ACB tree, a times c, 4 times -1 is -4, and b is 0. So two numbers that multiply to be -4 and add to be 0 are -2 and +2. Okay, so what do we do with these numbers? We split our middle term, but there's no middle term. We split 0, but there's no middle term. Well, let's tack some x's on here. -2x and 2x. That'll be our new middle term. We'll keep the front. These will be our middle terms with x's, and then we'll keep the back. So we've got 4x squared minus 2x plus 2x minus 1. Oh, I get it. If we had added these back together, that would give us 0x. So that does work. Okay. Then let's group the first two and the second two. Take out a GCF. From this group, we'd get 2x, and we're left with 2x minus 1. Greatest common factor here is just 1, so we get 2x minus 1. So our factors are 2x minus 1, the factor in parentheses, that's the same. And then the leftovers, the GCFs, make our other factor 2x plus 1. That is our answer here. Okay, got it. So let's factor this next one. 9x squared minus 16. That also doesn't have a b term. Interesting. Our a is 9, our b is 0, our c is -16. So a times c, 9 times -16. I have no idea. What is 9 times -16? 10 times -16 would be 160. I only need 9 16s, so 160 minus 16, 144, is that right? 9 times 16? -144, okay. -144, our b term is 0. Again, we need two numbers that multiply to be -144 and add to be nothing. So we've got -12 and +12. Multiplies to -144, adds to nothing. So again, we split our middle into -12x and +12x. Keep the front. 9x squared minus 12x plus 12x minus 16. Group the first two and the second two. Take out a GCF, which would be 3x. And we're left with 3x minus 4. Take out our GCF here, which would be 4. We're left with 3x minus 4. Great, parts in the middle, or sorry, parts in the parentheses are the same. So our factors are the part in parentheses, 3x minus 4, and the GCFs, 3x plus 4. Interesting. This was 2x minus 1 times 2x plus 1. This became 3x minus 4 times 3x plus 4. I wonder if there's something there. Let's look at this last one. The a is 25. There's no b term again. B is again nothing, and c is -4. So, a times c. 25 times -4 is -100. b is still 0. Two numbers that multiply to be -100 add to be nothing. -10 and +10. Split our middle term. 2x squared minus 10x plus 10x minus 4. Group the first two. Group the second two. GCF here is 2x, x minus 5. And we could take out a... we could take out feel like something went goofy here. Oh yes, it totally did, because that's supposed to be a 25. Ooh, 25. Much better. Now I'm taking out a 5x. Much better. Taking out a 5x, I'm left with, oh lord, this is a mess. It's okay. This should be 5x minus 2. 5x minus 2. Now here I can take out a 2 and get 5x minus 2. Much better. Those parts are the same. So one of my factors is 5x minus 2. The GCFs are the other factor, 5x plus 2. Do we notice something that these have in common? Yes, the two factors are almost the same, but one has a plus and one has a minus. One has a minus, one has a plus. One has a minus, one has a plus. Yes, we notice something in common. Factors are almost the same, but one has plus and other has a minus in the middle. Interesting. Any other patterns we see here? We started off with 4x squared minus 1, and we got 2x minus 1 and 2x plus 1. This became, or the second one was 9x squared minus 16. That became 3x minus 4 and 3x plus 4. This was 25x squared minus 4. This became 5x minus 2, 5x plus 2. It's like the front part of this is the square root of the front part of this. And the back part's the square root of the back. Ho-ho! That's exactly what this is. A general rule. If you have something squared minus something else squared, that will always factor to a plus b times a minus b. You can remember that shortcut forever. You never need to do an ACB tree if you have a difference, meaning subtraction, of squares. Woohoo! I love shortcuts. That's what math magicians do. We do as little work as possible. We're as efficient as we possibly can be. So we've got a general rule. If you have something squared minus something else squared, it will factor to a plus b times a minus b. Let's look and see what kind of examples we got here. Oh, look. There's a chart. Great. Table with the exact same rule we came up with. So, first we need to decide, is this a difference of squares? Well, it's definitely a difference. It's definitely got minus. Is 4y squared something squared? Why, yes it is. It is 2y, all of that squared. Is 36y to the 6th something squared? Something to the 6th? How could that possibly be something squared? I mean, I know 36 is 6 squared, but how would I get y to the 6th out of something squared? What do I remember about my exponent rules? If I have a power to a power, then I multiply. So what number needs to go as an exponent to the y to make it come out as a 6? Oh, cube. Because y cubed squared would be y to the 3 times 2, which would be 6. So this is a difference of squares. So how is this going to factor using this rule? Well, my a in this case is 2y, and my b in this case is 6y cubed. So this is going to factor to 2y plus 6y cubed times 2y minus 6y cubed. One for the plus and one for the minus. Sweet. Example number 2. Is this something squared? No, definitely not. I do notice there's a greatest common factor here. I wonder if we could start with that. It goes into both 18 and 50. 2 does. So let's take out a 2 first. And then we'll get 9x squared minus 25. Now, is this a difference of squares? Well, 9 is 3 squared. X squared is x squared. 25 is 5 squared. Yeah, it is. Totally is. This is really 3x squared minus 5 squared. So my a is 3x and my b is 5. So this is going to be 2, our GCF we took out, times 3x minus 5 times 3x plus 5. Nice. All right. Here's some you tries. Factor completely using your difference of squares formula. All right, a little word to the wise. Difference of squares factoring. Not going to work for sum of squares. Not going to work at all. Because it's not true. Just straight up not true. So don't use difference of squares factoring to handle sum of squares. Don't do it. Now let's talk about factoring by grouping. This we've kind of already been doing with our ACB tree. When we group the first two and group the second two, that's what we're going to do here. So let's group the first two and group the second two and take out our greatest common factors. Be careful, I put my parentheses right here so I could group the first two and group the second two. I'm not saying multiply this together. My parentheses here are for the grouping. This does not mean multiply. Okay. All right, if we look at the first group, what's our greatest common factor? We could take out a 2 and an x squared. So let's take out 2x squared. We'll be left with 7x plus 8. Okay. What's our greatest common factor here? Let's take out a negative 2. So we could get 7x plus 8, because remember we want the part in parentheses to be exactly the same. So now we've got 7x plus 8 times 2x squared minus 2. This factor here has a greatest common factor, which tells me I should have taken out a greatest common factor at the very beginning. Oh no! Should have taken out GCF at beginning. Blarg. Let's go back. What should I have taken out at the very beginning? Definitely should have taken out a 2. So let's back all the way up. Back up. Take out a GCF of 2. We'll be left with 7x cubed plus 8x squared minus 7x minus 8. Gotcha. All right, now let's group the first two. The second two, what can I take out here? Now all I can take out is x squared. So I've got my greatest common factor. I've got my x squared. I'm left with 7x plus 8. Let's take out a negative 1 so that we can get our factor to be the same, 7x plus 8. So now our answer is our greatest common factor times our factor that was the same, 7x plus 8 times our GCFs we took out, x squared minus 1. Whoa, what's that? That's a difference of squares. That is x squared minus 1 squared. That means I can factor that to x plus 1 times x minus 1. So this is going to be all together 2 times 7x plus 8 times x plus 1 times x minus 1. Whee! Very good. Which we would have missed if we would have stopped right here and not taken out our greatest common factor at the beginning. Good thing we caught that mistake. All right. We won't forget it this time. Is there a greatest common factor in example number 4? 15 and 56. I don't think 56 is divisible by 3, so that's not going to... nope. No GCF. We're not in danger of having an issue like we did last time. Let's group our first two and group our second two. Again, this does not mean I'm multiplying. It just means I'm grouping the 2's and 2's together. Wait. What? This is already going to be a problem. Why is this going to be a problem? My goal is to get something factored where the parts in parentheses are the same. This has a y. Nobody else... What? We're going to have to rearrange this first. I have to rearrange this so that it's possible that we get our parts in parentheses to be the same. So let's part the things that have the y's together. Let's rearrange. So this is 15xy plus 21y. And then let's do minus 40x minus 56. So let's group these together, and let's try it out. What's the greatest common factor between these two? Well, they each have a y that we can take out, and they're both divisible by 3. So let's take out a 3y. And we'll be left with 5x plus 7. Now this one, we could take out a negative 8. And we'll get 5x plus 7. Now we got our parts in parentheses that are the same, which we wouldn't have gotten if we didn't rearrange. Okay. If we tried to take out a GCF from this very original part here, there is nothing. There literally is no greatest common factor between 15xy and negative 56. It just wasn't going to work. So we needed to rearrange, put the parts that had the y's together so that we could take that out, so that we could get two factors that were the same in parentheses. So this will factor to the part in parentheses times the greatest common factors, 3y minus 8. And that will be our final answer. Okay. Looks like you are the winner chicken dinner on these next two questions. And one last little boost. If you have 6 terms, you can make groups of 2 or groups of 3. Let's check out, see what we've got. 2x cubed plus 3x squared minus 5x plus 8x squared y plus 12xy minus 20y. Let's see. I think let's go with groups of 3. Let's do groups of 3. So let's put these 3 together. Those all have x's. Let's put these 3 together. Those all have some y's. Okay, so let's deal with these separately. Greatest common factor of this group here is x times 2x squared plus 3x minus 5. Greatest common factor here, they definitely all have a y. We can also divide them by 4. Yeah. So let's take out a 4y. We'll be left with 2x squared plus 3x minus 5. That worked out great. Those parts in parentheses are the same. Sweet. So we've got the part in parentheses, 2x squared minus 3x minus 5 times x plus 4y. I feel like that's supposed to be a plus, because it is. Now this kind of smacks to me of maybe something that could be factorable by an ACB tree, where A is 2, B is 3, and C is negative 5. So let's see what we can do with that. A times C and B, A times C, 2 times negative 5 is negative 10. Add to 3, do I have two numbers that could multiply to negative 10 and add to positive 3? I sure do. Negative 2 and positive 5 would multiply to negative 10, add to positive 3. So let's split our middle then. I'm just dealing with this trinomial. So we've got 2x squared minus 2x plus 5x minus 5. Group the first two, group the second two, take out a GCF, 2x, x minus 1, take out a GCF, that's going to be 5, x minus 1. So this factors to 2x plus 5 times x minus 1. And then I'll bring down the other factor we had of x plus 4y. And that will be our final answer here. So we did groups of 3 and found another thing we could factor using one of our other tools, our ACB tree, and got down to our 3 factors here. And last but not least, it's all you. All you. I'd put your A's together and your B's together. That's my suggestion here. All right, what did we talk about? Factoring difference of squares. All this hard work, and we came up with a beautiful little punchline. If you have two things squared and a subtraction sign in the middle, a difference of squares, it will factor very nicely into whatever that one was, plus that guy times that one minus that one. A plus B times A minus B. We said don't use that for a sum of squares. It's not true. It doesn't work. Don't do it. And then we talked about factoring by grouping, which again you've been doing for quite a long time. Don't forget to take out a GCF. If you see a difference of squares after you've used another factoring method, like factoring by grouping, factor with difference of squares as well. Okay? Don't forget that last step. Rearrange if you need to, so that you can get these parts in parentheses to be the same, so you can do this grouping factoring. And you can even do it if you've got groups of 3. That'll still work. All right, that's it, scholars. Love you so much. Keep on the hustle, and I'll see you next time.